Betelgeuse, a Goliath red star situated at the outer reaches of our cosmic area, is a wonder. If it were placed where the Sun is, its size would stretch out to the orbit of Jupiter. This massive and unusual giant is primed for a blast of unbelievable proportions. Prepare yourself for an event of cosmic significance. Betelgeuse, the red supergiant star on the fringe of our solar system, is sending alarming signals across the vast expanse of space. Astronomers have uncovered something disturbing about this gigantic star using the James Webb Space Telescope. Renowned scientist Brian Cox has issued a warning. The pressing question is whether we are on the brink of witnessing a massive explosion that will alter the night sky forever. The mystery of Betelgeuse lies within the infinite vastness of the universe. Stars are born, live, and die in extraordinary ways. Recently, one star has captured both the attention and concern of astronomers and the public. Betelgeuse, a red supergiant star in the Orion constellation. It is immensely large and old, with its distinctive reddish tint and fluctuating brightness long enchanting observers. Recent developments have heightened interest in this colossal entity, and as we learn more about Betelgeuse, we may be approaching a pivotal moment in its life cycle. But what do these changes signify? Are we witnessing the early stages of a cosmic spectacle of unimaginable scale? Betelgeuse's colossal size and its life cycle are key elements in understanding its significance. This star is approximately 1,000 times the size of our Sun, making its magnitude nearly unbelievable. Imagine a star so large that, if it replaced the Sun, its surface would reach beyond the orbit of Mars, enveloping Mercury, Venus, Earth, and Mars. This immense size not only demonstrates Betelgeuse's staggering scale, but also reveals its current position in the stellar life cycle as a red supergiant. Betelgeuse is nearing its dramatic end, expanding and cooling after depleting its hydrogen fuel and fusing helium. It is estimated to be between 8 and 8.5 million years old. Although this is relatively young by human standards, it is ancient in cosmic terms. Over millions of years, Betelgeuse has undergone dramatic changes, evolving from a hot blue star into the red giant we observe today. It is now in the final stage of its life. As a red supergiant, Betelgeuse experiences significant changes due to the constant forces of nuclear fusion and gravity. A key feature of Betelgeuse's current phase is its reddish color. This hue arises from its cooler surface temperature compared to stars like our Sun. The Sun's surface temperature is around 5,500 K, while Betelgeuse's is much cooler, at around 3,500 K. This cooler temperature causes Betelgeuse to emit light at wavelengths that give it a red appearance, reflecting ongoing processes within its massive gaseous structure. The fact that Betelgeuse's color has shifted over time adds another layer of intrigue. Ancient records, including those from Roman and Chinese civilizations, suggest that Betelgeuse was yellow as recently as 2,000 years ago. By the 9th century, Arabic astronomers began noting its red hue. This change in color over the centuries signifies the star's evolution. A fascinating aspect of Betelgeuse is its fluctuating brightness. It is a semi-regular variable star, meaning its luminosity changes periodically. These cycles of dimming and brightening have captivated astronomers for centuries. Typically, Betelgeuse undergoes 400-day cycles and longer 5-year cycles. As early as 1836, Sir John Herschel recorded these variations, and Native American oral traditions may date back even further. However, what makes Betelgeuse particularly puzzling is the irregularity of these brightness changes. Unlike many stars that exhibit predictable fluctuations, Betelgeuse sometimes deviates from this pattern, suggesting complex and not fully understood processes within its massive structure. Recently, astronomers were stunned by a sudden and dramatic change in Betelgeuse's appearance. This unusual dimming event, known as the Great Dimming, began in late 2019. Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the Orion constellation, started to fade mysteriously. The dimming occurred so rapidly that Betelgeuse's light was decreasing at a rate of 0.01 magnitudes per day. By February 2020, the star was at its dimmest. Remarkably, Betelgeuse, which is typically visible to the naked eye even in areas with significant light pollution, became faint, and even casual observers noticed the difference. The mystery of the time delay complicates our understanding of Betelgeuse's behavior. Light from the star takes approximately 725 years to reach Earth. Therefore, what we observe now reflects events that occurred centuries ago. At the point when we notice Scarab Jew, we are seeing it as it showed up hundreds of years prior, not as it is currently. This delay makes it hard to anticipate and screen quick changes in its conduct. Andrea Dupree, the head of the Center for Astronomy at Harvard and Smithsonian, and her group firmly followed Betelgeuse's grandiose activity as a component of a 3-year study to observe changes in the star's external environment. They utilized the Hubble Space Telescope to study the star, giving new insights into the nature of variable stars. Variable stars like Betelgeuse expand and contract continually, causing fluctuations in their brightness. Thanks to Hubble's sensitivity to ultraviolet light, astronomers were able to observe the layers above Betelgeuse's surface, which are heated by the star's whirling convection cells. Spectroscopic data gathered from Hubble in 2019 and 2020 revealed significant changes in Betelgeuse's upper atmosphere. The spectra primarily showed magnesium, indicating that material was being ejected from the star's surface into space at velocities of around 200,000 miles per hour. This emission and mass loss lasted for several months, with material traveling millions of miles from the star, creating a dust cloud that dimmed Betelgeuse's light. Dupree and her team found that the amount of material ejected from Betelgeuse's southern hemisphere was twice as much as expected. While it is typical for stars to lose mass over time, Betelgeuse's mass loss was occurring at a rate much faster than the Sun's. Astronomers speculated whether this event could signal the impending supernova of Betelgeuse, given the star's size, the massive ejection of material, and the dimming. Researchers wondered if this could be an early indication of a catastrophic end. At 725 light-years away, any explosion from Betelgeuse would be visible from Earth, presenting a unique opportunity to study a supernova up close. The question remains, what does this dimming mean for Betelgeuse's future? Is it the precursor to an imminent supernova, or is it merely a temporary event in the star's long and complex life? Several theories have been proposed to explain the rapid dimming. 1. Early stage of supernova. One popular hypothesis suggests that this could be a sign that Betelgeuse is nearing the end of its life. 2. Dust cloud obstruction. Another theory posits that dust, possibly ejected by the star itself, could be obstructing our view. Red supergiants like Betelgeuse often shed material, which can accumulate into a dust cloud thick enough to obscure the star's light. 3. Photosphere changes. A third theory suggests that changes in the star's photosphere, its visible outer layer, might be responsible for the dimming. Spectroscopic analyses indicated that Betelgeuse's effective temperature had decreased by at least 170 K during the dimming, supporting the idea of significant changes on its surface. The Hubble Space Telescope played a crucial role in unraveling this mystery. Its observations showed that the dimming was likely due to a large amount of hot material being ejected into space. This material formed a dust cloud that blocked light from about a quarter of the star's surface. The dust cloud consisted of plasma that traveled from Betelgeuse's hot atmosphere to cooler outer layers, forming dust grains that obscured light. The impact of this ejected material was clearly visible from Hubble's ultraviolet spectroscopic data, which began in January 2019. These observations provided essential data about the material moving through the star's atmosphere long before the dimming occurred. Several ground-based telescopes also observed the brightness decrease starting in December 2019, which Hubble confirmed and elaborated upon. The realization that Betelgeuse was losing material at a faster rate than previously thought has significant implications for our understanding of stellar evolution, especially for red supergiants. It is important to note that Betelgeuse is not the only star undergoing such dramatic changes. Other historical supernovae, such as SN 1054 and SN 1987A, have provided valuable insights into the death of stars and the formation of new elements. If Betelgeuse eventually becomes a supernova, it would create a spectacular light show visible from Earth. The explosion would be brighter than the Moon and might even be seen during the day. This event would offer a unique opportunity to study the final stages of a massive star's life and the dispersal of heavy elements across the universe. However, the distance between Betelgeuse and Earth ensures that any such explosion would not directly harm us. In conclusion, the ongoing observations of Betelgeuse's potential transformation will continue to expand our understanding of stellar evolution and cosmic phenomena. Red supergiants like Betelgeuse play a crucial role in the life cycle of stars, and their explosive deaths contribute to the formation of heavy elements essential for the creation of planets and life. Studying stars like Betelgeuse offers valuable insights into the final stages of stellar development and the processes that shape our universe. The continued study of Betelgeuse and other red supergiants not only enhances our understanding of stellar evolution but also contributes to answering larger questions about the universe's life cycle. Astronomers remain focused on determining whether Betelgeuse's dimming signals a supernova in the making, or if it reflects typical fluctuations in a red supergiant's late stages of life. The unique behavior observed in Betelgeuse may help refine existing models of how massive stars end their lives. Should Betelgeuse undergo a supernova, it would offer unprecedented opportunities for scientific observation. Researchers could study the immediate aftermath of such an explosion, including the shock waves, the newly formed nebula, and the enrichment of the interstellar medium with heavy elements like carbon, oxygen, and iron. These elements are critical for forming planets, stars, and potentially life itself. Additionally, observing Betelgeuse's transformation provides a rare chance to witness phenomena that are integral to understanding cosmic recycling. Stars like Betelgeuse play a central role in the universe's ecosystem by spreading elements that seed the formation of future celestial objects. In the meantime, the scientific community is working to develop new technologies and techniques to monitor stars like Betelgeuse more closely. Instruments such as the James Webb Space Telescope, JWST, and ground-based observatories will likely contribute further to tracking these extraordinary events. These observations will complement ongoing efforts by Hubble and other telescopes, creating a more comprehensive picture of how massive stars evolve, shed mass, and ultimately explode. While the mystery of Betelgeuse's dimming persists, it remains a reminder of the dynamic and ever-changing nature of the cosmos. The universe is full of surprises, and each discovery brings us closer to understanding the intricate processes that govern the stars, galaxies, and the very fabric of existence. Betelgeuse, in its brilliance and volatility, embodies the cosmic dance of creation and destruction. Its story, whether it culminates in a supernova or continues its fluctuations for millennia, is a testament to the awe-inspiring forces that shape our universe. Scientists, stargazers, and humanity as a whole eagerly await the next chapter in Betelgeuse's journey, knowing it holds lessons that will resonate far beyond our corner of the cosmos.